All
Hey,
right. Hello, hello. I believe that now people should be able to hear us. Hello, everyone. Could you please let us know on the chat if you can indeed hear us? You see some eyes. Yes, beautiful. Excellent.
a lot
Excellent.
of yeses.
Yay. Thank you so much for being so reactive. Very happy to read everyone is here. Um, Several people may still be coming. Maybe to kick off, if you guys don't mind, just let us know, what you teach, and if you don't teach, what you do, and just also where you come from. And it's such a large state, California, that it'd be curious. I've been traveling. I'm from Spain, from Barcelona, and for those of you who don't know me, and I've been traveling across very interesting places in the north of California that are so far away, I wouldn't think it's California, but it is. So,
And then
anyway,
we lose the reference with miles sometimes. So it's
that's a very fair point. When I ran my marathon the last time, it's like 26 miles sounds tough. 42 kilometers is worse, but then it's like, well, mm,
Hmm.
you need to work on that conversion. Like, you're not sure what you prefer. Mm. Anyway, beautiful. See a lot of different people. San Diego, San Jose, uh-huh.
Los
Paris,
Angeles.
LA, yes. Pomona, beautiful. I see some people that came also last week. Hello to you. Excellent. I mean, I would say let's get started to make the most of the exciting session that we have ahead of us today. So my name is Renat, for those of you that can see, and I'm part of the team at Inomat. As I said, as I hinted, I'm from Barcelona, Spain, but now I live here in the US, in California specifically, in San Francisco. And I have two amazing human beings with me joining us today. Our featured speaker, Howie Hua, who I'll introduce in a second, and Dr. Albert Vilalta, who is part of our team at Inomat as well. I wanted to introduce the session just 1 minute before we dive in. Essentially, today is going to be about number sense. And I wanted to kind of preface by saying, I mean, I know that probably every one of us in this room, we've read the framework, we've taken the time to think about what it means and the implications that this has for us in our classroom, in our site, in our district. And it's a long document, right? I mean, it's a document that's dense, but it's very rich as well. It has a lot of insights from a math education and pedagogical standpoint that are valuable. And in this sense, part of our work at Inomat as a math education organization is to try and share that message with you through the voices of who we believe are the people that know the most and that are amazing speakers in the community. And today I'm just like super excited to introduce you to Howie, who I'm sure all of you or many of you know, so probably doesn't need an introduction. I still will introduce him. And I wanted to kind of take a second to read his bio, if you guys don't mind. I am always very informal, but nonetheless, I want to value everyone's journey and work. So I'll take just 30 seconds. Howie is a math instructor at Fresno State, where he teaches math to future elementary school teachers. He's on the journey to show students that everyone is a math person, which is amazing. In 2019, Howie was awarded Outstanding Lecturer for Fresno State's College of Science and Math. In 2024, he also was awarded the Provost Award for Outstanding Lecturer. As you may have seen him, he has given a lot of talks to organizations over 20 states and 4 countries. And he was also a closing keynote speaker at the NCTM's annual conference in 2024. I was there, so I can tell. As you know, one can find him on social media, sharing a lot of amazing videos and tips, which I believe like democratize the access to math education. That's something that we certainly value. So anyway, Howie, super excited to have you with us today, and I'll just pass it along to you.
Great. Thank you, Bernard. Hi, everyone. Thank you so much for being here. Before we start, I took this picture in Morro Bay. How many small squares are here? And how did you count? So type in the chat, how many small squares do you see? So each of those individual tiles. Can you write maybe a number sentence describing it? So just type it in the chat whenever you're ready. Hi, Keith. Thanks for being here. Okay, so let's see. 3 times 5 plus 4 times 4. Hmm. So you have 4 times 4 plus 3 times 3. I like all of these number sentences. Multiplication, just addition, just multiplication. First 4 rows is n squared, so 16. Great, awesome. 1 plus 3 plus 5 plus 7 plus 5 plus 3 plus 1. I want to emphasize Marcia. So if you can look at Marcia's, I posted this on TikTok a couple years ago, and I just asked how many small squares are here, and someone said, take the top, bottom, left, and right ones, move them to the corners. And when we do that, we get a 5 by 5 square, and that blew my mind because 5 by 5, right? It's just 25. So I love that. Thank you so much. Like Bernard said, I am a math instructor at Fresno State, and feel free to um, email me for the slides at the end of this slide deck. You will be able to ask for the slides as well. So thank you all for being here. It really means a lot. You could have been anywhere else, but you decided to be here. And I hope you get what you need in this session. So I'm going to talk about chapter 3 of the framework, number sense. So what does the California Math Framework say about number sense in K-12? I want to share rich tasks that help students develop number sense. And then the last part, Albert is going to share an activity from AnovaMath that helps build number sense. So let's talk about the overview. It's about 50 pages long. So we're going to go through the grade bands and then talk about the general tasks that we can incorporate. So let's start with TK2. So, for example, it's not just about answer getting, it's about comparisons as well. For example, like how can you show that 8 plus 6 is equal to 10 plus 4, right? Think about that depth of knowledge. It's not just what is 8 plus 6, but the reasoning of how we know that 8 plus 6 is equal to 10 plus 4. Do you know what property we are using when we do this? So type it in the chat. Do we know what property we are talking about when we move part of a number and give it to the other? Type it in the chat. What property is that? Yes, it is associative. I remember when I was in elementary school, I'm like, why are we learning this? Because remember, it's like A plus B plus C equals A plus B plus C. I'm like, what's the point? But it's literally just moving things around with addition and multiplication. It is just moving things around the associative property. I saw this picture on, I think, Reddit a year ago, and this parent said, like, I have no idea what's happening in my children's homework. So just take a look at this problem and think to yourself, what should be in this box and what should be in those blank lines? So take a couple seconds. What is this trying to do? I'm loving this. Number bonds, trying to proceduralize the associative property, decomposing 3 to make friendly numbers. Yeah, so trying to find a benchmark number. 12 minus 2 is 10. That's a nice number to land on. Oh, we need to take away 3. We took away 2 so far. We need to take one more. 10 minus 1 is 9, so 12 minus 3 is 9. And we can do this with larger numbers as well. Maybe it's like 112 minus 16, right? We can apply that to do subtract 12, subtract 4 when we subtract 16. So I love this reasoning of just building a nice benchmark like 10. Yeah, Vicky says make a 10. And here's another one. They also talked about comparisons, which one's larger, which one's smaller. in TK12. I got this from Flynn Education, Mike Flynn. Um, he has on his website something called Is It Fair, which is just two plates. Does A equal B? Is A more than B? Is it fair? So students can subitize or think about 10 frames to think, is this fair? To do comparisons. And also, once again, subitizing. How many holes? How did you count? I took this picture at Fresno State. So take a couple seconds. Give me a number sentence. How would you count these holes? Angel, were you at CMC South? Your name sounds familiar. Great, awesome. Thanks for being at my session again. Oh, Candace was at CMC South too. Great. Yeah, so with these dot talk images, the framework talks about dot talks. We can use this to connect to number sentences as well, like we are doing right now. Like Joseph says, 4 times 3 plus 2 times 2. So I'm assuming you're seeing these as columns. Brittany sees 4 plus 4 plus 4 plus 4. Correct me if I'm wrong. Are you seeing the fours on the columns on the ends and then like two diamonds? Do you see that? Great, awesome. Joseph says also Windows in band drill. I don't know if all of you know this, but Joseph and I have a drum corps connection. So that's really cool. And Vince says 8 times 2, the top twice. So we see 8 on the top and then it's repeated on the bottom. This is actually my first mathematical activity I do with my students on the second day. I asked them, how many holes are there? They all said 16. I said, great. I could have said, let's move on because we all got the right answer. But if we just move on, we lose out on the beauty of math, which is very often found in the process. For one time, a student saw a butterfly. So do we see a butterfly? We see 4 as the body and then 6 and 6 for the wings. Bernard, can you see my mouse? Like if I move it? You can? Okay, great. Yeah.
Yes.
6 and 6 for the wings. So it's really cool because I tell them this is my first mathematical activity because something that's obvious to you may not be obvious to someone else. So please share what you're thinking throughout this process. They also talked about number talks and number strings as well. I love number talks because, once again, beauty of math is very often found in the process. So I posted a mental math Monday. Would you mentally calculate 17 plus 18? And it kind of went viral. And then the co-creator of Phineas and Ferb commented saying 8 plus 7 is 15 plus 20 for the 2 10s equals 35. And I like to think of people's ideas as gifts because you don't know what they were thinking before they said it. So it's all about thinking about that, seeing that there are so many different ways of doing math, right? I teach math to future elementary school teachers, and several students would say, like, well, I would always get the math right, but I didn't do it the teacher's way, so I got marked wrong, right? But math is so open. There are so many different ways of doing math. So just be open that there are so many different ways of doing math. I really like this quote from page 15. So on page 15, they said, it is imperative that students implement a standard method only after they have fully developed an understanding of the operation, can connect previous strategies and representations to the steps of the algorithm, and make sense of this abstract process. I'm going to be completely honest right now. Did not understand what the long division algorithm was talking about until like 5 years ago, because all I did was just follow the procedures to get the answer. I'm not talking about it in this talk, but all we are doing is just sharing, right? All we are doing is just sharing using the partitive model, splitting into equal groups. So yeah, I really wish that I was taught where we understood what division actually was and then go on to the algorithm. So let's move on to 3rd to 5th grade. They emphasize more number lines. So on the third day of class, I do number talks with subtraction. So number talks, fist on your chest, number of fingers up means how many different ways you can do it. And yes, Angel, it is chapter 3, page 15, chapter 3, page 15. So when I was doing the number talk with my students, they did a lot of addition problems pretty fine. But with subtraction, they barely had one finger up. They're like, I don't know anything else besides the standard method. And then I told them, think about a number line. If you start at 18, how can you get to 41? So just having this structure, students can come up with so many different ways. So for the first way, I call it friendly jumps because you're jumping by tens until you can't anymore. The second strategy I call friendly checkpoints because you're landing on nice numbers. 20 is a nice checkpoint between 18 and 41. And students really like this last one, called same distance, same difference, or constant difference. I like to talk about age gap with this one. So, for example, if you are 18 and your uncle is 41, when you turn 20, they're going to turn 43, right? The distance is preserved, but 20 to 43 is a lot easier than 18 to 41. So, just that flexibility with the number line. The chapter also says multiplication, can they see it as groups on the number line and as an array, right? So multiplication is very visual. And we can also talk about strategies to make things easier. We talk about fluency a lot. They define fluency as accuracy, flexibility, and efficiency. So for example, 10,000 minus 4,289, we could just do the stacking method. We can. We could also count up or subtract one from each number and then subtract. Joseph says vertical lines could be helpful as well. Yes, vertical number lines like on a thermometer. I was doing a school assembly for third to fifth graders in Redding, California, and I shared this SpongeBob meme. And then a fourth grade teacher came up to me afterwards. She was like, that SpongeBob meme that you showed, and she shook her head. I was like, am I in trouble? Like, am I not invited to Reading anymore? And then she said, I need to apologize to my fourth graders because it's so much easier, right? You don't have to regroup 4 times. You could just subtract one from both numbers and then subtract. Now, I know that this may be very common. Something else that's not as common is doing it with mixed numbers, right? We can be playful with mixed numbers as well. It's the idea of same distance, same difference. It's very nice if the subtrahend, right, what we're taking away, is a whole number, right? So 4 and 5/8 minus 3 is a lot easier than 4.5 minus 2 and 7/8. So just this idea of being flexible with our numbers, knowing that we can preserve, as long as we preserve distance, we're going to get the right answer. And same thing with partial quotients, right? It's all about fluency, which is efficiency, accuracy, and flexibility. So for example, someone who feels comfortable with division can think of it as how many fives are in this number. They can say, well, I know 10,000 fives is 50,000. I went over by one set of 5. So the answer is 9,999. So now let's go to 6th to 8th grade. I know I'm totally speed running this. Like, it's a 50-page document, so I'm so sorry for just kind of speed running this. But now let's talk about 6th to 8th grade. I really like doing where's that decimal. So I do this with my students. I purposely take away a digit or two at the very end to have them focus on estimation so they don't just count digits after the decimal. So with 6th to 8th grade, they talk about estimation. They talk about, do they really understand the procedures? So for example, with number 1, we can use estimation saying like 5 times 6 is 30. So the answer should be a little above 30. The only place the decimal point would make sense is after the 6, 36.094. And I would do this with multiplication and division to show them that we don't have to rely on counting digits after the decimal point. We can absolutely use estimation to figure out where the decimal point makes the most sense. And also building fluency, we can talk about subtracting left to right. So I didn't learn this until maybe 7 years ago from James Tanton. James Tanton, if you don't know him, he's very big on just do whatever you want and deal with the consequences later. So if we allow negatives to happen, just deal with the consequences. So with 83 minus 16, 8 minus 1 is 7. 3 minus 6 is negative 3. So that's not 7 minus 3. It's 70 minus 3, which is 67. And I want you to try the right one out by yourself. 362 minus 175. I want you to practice going left to right. So 3 minus 1 is 2. 6 minus 7 is negative 1. And 2 minus 5 is negative 3. Now, it's not 2 minus 1 minus 3. Think about place value. It's 200 minus 10 minus 3. Now, if I were doing it for the first time, I wouldn't write it like this. Instead, I would write 200. I would say 300 minus 100 is 200. 60 minus 70 is negative 10. And 2 minus 5 is negative 3. Have it vertical, so it's 200 minus 10 minus 3, so students can see this, and then move to shorthand from there. So we can still learn mental math tricks or different ways of subtracting in 7th grade. I would recommend 7th grade because that's when they do integer addition and subtraction to apply it. But I've posted videos on this, and some teachers in 3rd grade said that their 3rd grade students prefer this way more. They also talked about estimation with percentages as well. Brittany, what is this way called again? We call it subtracting left to right. Yeah, thank you. Percentage problems. If you don't know Dwayne Hobbecker, very big on tape diagrams, bar models. So if a store raised all of their prices by 25%, if the increased price is $160, what was the original price of the jacket, right? So we know that the answer is less than $160. So we could draw a bar model to visualize this. I can see that 125% is 160. I only need 4 of these, so let's split into 5 parts, and I want 4 of those parts. And it's very important to connect to the abstract because students are so used to seeing 1.25x equals 160, divide both sides by 1 and 25 hundredths. But if we write these as fractions, because fractions are our friends, do we see this 5/4 anywhere? And do we see why we want 4/5 of $160? Right? We can see visually why we want 4/5 of $160. So very important to connect the CRA model, concrete, representational, abstract. So we have that representational in here, not just go straight to the abstract. I was just teaching my students this last week. The framework says a lot about cross multiplying, saying that I don't want to be hyperbolic, but like the dangers of cross multiplying because they lose sense about the number sense if we just focus on cross multiplying. So I gave this problem to my students last week or last week, saying, should we cross multiply? Keith says, yeah, they call it pitfalls. Yeah, pitfalls with proportions. So I tell them, like, if x is in the numerator, definitely don't cross multiply because that's just like that. You're just doing an extra step. You don't need it. But even if it's in the denominator, maybe look for a scale factor. For example, the second one, we can say 3 times 4 is 12. So 7 times 4 is 28, right? So just focusing on, I think they asked you to write it as tables instead, to focus on that. But just like Keith says, pitfalls with proportions. I saw a Facebook comment saying that once you teach cross multiplying, everything becomes cross multiplying. So make sure that we really understand that all we're doing is just isolating x. If it's in the numerator, definitely don't cross multiply. But if it's in the denominator, maybe look for a scale factor, right? So we don't always have to cross multiply. All right, let's go to high school. They do talk about developing financial literacy. That's going to make this talk way too long. So I just want to focus on number one, the first one, the parallels between numbers and polynomials. So I want us to think about multiplication and the through line of multiplication with area models. So in elementary, they're taught with an area model, breaking it down by place value. And we can also do this with mixed number multiplication. Same thing. And then connect it to polynomial multiplication, right? Literally looks the same. So when we have this through line of whenever we have two numbers multiplied together, just think about an area model. It's going to make this a lot more seamless. We don't have to worry about FOIL, or I saw a video about like lobster claws. It's like, nope, just we could just do the distributive property and area model. So I want to talk about two math tricks involving algebra. So I know that a lot of people say, like, when am I ever going to distribute? When am I ever going to distribute a polynomial and all of that? But if you teach algebra, definitely teach math tricks because a whole bunch of math tricks are rooted in algebra. So here's one of my favorite math tricks, squaring numbers that end in 5. So I underline some digits for a reason. Use these patterns to figure out 75 squared and 45 squared. I always tell my students, math is the study of patterns. So what patterns do you notice? And use those patterns to figure out 75 squared and 45 squared. And once you're ready, just type it in the chat, what patterns you notice. All right, I love it. I want to challenge all of you. What about 105 squared? So we talked about like the tens place or the first digit. Can we extend this? Can we do it as 105 squared? Would that still work? Brenda says last numbers are always 25. So yeah, so using that sequence, I've also had people say it's the first digit squared plus that same digit, right? So like 3 squared plus 3, 6 squared plus 6. And we can see algebraically that that's the same thing as 3 times 4 or 6 times 7 or 7 times 8. So yeah. And once again, 105 squared does work. It's 10 times 11. 10 times 11 is 110. Tack on that 25 at the end. So we can use algebra to figure this out, why it works. All of these numbers are 10n plus 5 times itself for some whole number. And when we distribute and factor, we see why we don't always end in 25. And like everyone was saying in the chat, we have that n times n plus 1. So that's where that 3 times 4, that 6 times 7, that 10 times 11 comes in. So once again, if you're teaching algebra, you can show them this trick to see, hey, this is how distribution, that's how factoring can help us. And here's another one that builds on number sense. If you know 50 squared is 2,500, what is 51 squared? Right? So all we have to do is add double the original base and add 1. So it's 2,500 plus 2 times 50 plus 1. And the reason why this works is, once again, algebra. It's n plus 1 quantity squared. So we see that we have our original n squared, we add twice the base, and we add 1 to it. And we can see why visually, right? We have the original square, x times x, or n times n. And then when we want the next higher square, we would add 2 of that base and add 1. Right? So we don't have time to do these, but we can give these types of problems out to students because do students know multiplication if we are given 20 squared is 400, but they can't do 21 squared if they have to do it from scratch, right? So they can use the idea. Imagine this 20 by 20 square. I'm extending it by one, so I add this extra 20, add this extra 20, add this extra one. Can we visualize that area model, that square getting bigger? Right? So these are just two of many tricks that we can teach in algebra that help build fluency, that you can use something like 35 squared, which we learned in the last trick, to help us figure out 36 squared. We don't always have to start from scratch. So how can we embed fluency into a lesson or number sense into a lesson? We can do quick daily practice. It's all about connections. It's all about relationships, not starting from scratch every single time. So for example, how can knowing 10 plus 7 equals 17 help us with 9 plus 7? Or here's a multiplication problem. How can knowing 5 times 8 equals 40 help us with 6 times 8? So really emphasizing that, hey, I'm giving you something, use that as a relationship to build on another one. What about this one? Is the answer 168 or 166? Let me know in the chat. I know students would get confused on this, so is the answer 168 or 166? Yeah, 168. So we can think about subtraction as taking away. Maybe I have $192 and a dinner was $25. And they're like, oh, wait, it's actually $24. So you saved one more dollar, so it's 168. Andrew says subtract one less, so the answer is one more. Yeah, so think about that number line. Instead of subtracting 25, we could subtract 24. Oh, the answer is going to be greater. And type in the chat if you know open middle problems, yes or no. Just type in the chat, open middle problems, yes or no. Okay, maybe like 60-40 on open middle problems. Robert Kaplinsky, look up openmiddle.com. There are a lot of good problems that go higher in the depth of knowledge levels um, that really build fluency. So, for example, for comparisons, fraction comparisons, I like this one. Using the digits 0 to 9 without repetition, fill in the blanks, right? So rather than having a whole worksheet on fraction comparisons, they can spend half the period just working on this problem, right? And they have a whole bunch of trial and error for these. Another idea is broken calculators. I like this one. I made it up. How can you calculate 8 times 88 if the 8 key on the calculator is broken? So type in the chat. Yeah, Asia, I didn't make up the idea of broken calculator. I'm pretty sure I made this problem up. But broken calculator, I didn't make it up. But I think it's good to build that fluency. It's like, how else can I calculate 8 times 88 if I can't use an 8? So let's just take a couple minutes. I like that Angel and Andrew have the same idea. Take a factor of 2 out of both of them to make a 4. Ooh, my chow broke 8 into 1 plus 7 and 88 into 44 plus 4. 44. And I challenge you, can you do these mentally? So, can you manipulate this so you can do it mentally? Ooh, okay. Heidi says 10 minus 2 times 90 minus 2. I would have personally moved a factor of 8. So associative. Yeah, yeah, there you go. Brittany said it. I would move a factor of 8 from 88 and give it to 8 to make it 64 times 11. I know how to do multiplication by 11 in my head because it's 640 plus 64. So it's 704, right? So broken calculator. And here's another one. Here's one more. How can you calculate 215 minus 89 if the 9 is broken? So type in the chat, how would you do it? Great. I have a question for you all. If we change 89 to 88, if we change 89 to 88, would we turn 215 to 216 or 214? If we changed 89 to 88, would 215 turn to 214 or 216? If 89 turned to 88, it would be 214, right? Once again, the idea of same distance, same difference. Think about age gaps, right? No one's going to be 215. But if it's 215 to 89, right, it would be 214 to 88, right? Same distance, same difference. All right. So that was my part. Albert, I'm going to let you
Thank
have.
you, Howie. Thank you. No, I was still thinking about the broken calculator, which
Oh,
actually
yeah,
is an activity that we love and we have in the program because you can make so many variations, right? Just
absolutely.
choose your battle, pick your battle, like choose the keys that are not working, and you have a new challenge. And you can ask the kids to pose their own broken calculators to their classmates, and the fun is endless. So thank you so much. I'm gonna present my screen as we go. And let me see if that works. Can you see it? All right. So yeah, and actually that feeling of, oh yeah, this activity or this idea, I love how you explain it and how you frame it and how the framework also emphasize this idea of number sense and fluency and give this flexibility at the end of the day that allows us to do this math in a more, I would say, in a more pattern-seeking way, as you were saying. I love the definition of math as the science of patterns as well. And when you ask mathematicians, they all answer the same, right? They don't say, no, I always do the vertical algorithm. So I love that. Okay, so we're gonna do an activity, and just before that, I wanna and Howie, you just mentioned this, so this won't be new for the audience. How we and when I say we, it's a very extensive we. I took this from Jennifer Bay Williams, a friend, and one true reference when it comes to talk about fluency. And I had the luck of seeing her and John Chan Giovanni talk about fluency a few years ago at an NCTM conference. And since then, I mean, of course, there are many authors talking about fluency, but Jennifer Bay Williams is also is always a good reference. And she defined with Johnson Giovanni in that webinar, she defined fluency with these three components that might be almost obvious today because everyone is talking about fluency. But back in the days when we were understanding fluency as only speed, this was rather new, right? And understanding that speed is just an indicator that might be interesting or not, depending on your situation. But in general, fluency is much more, right? And it is defined as these three components that we were talking about, right? Efficiency, flexibility, and also accuracy. We cannot forget that you have to be right in the end when you're performing calculations and operations. And you can see here the indicators. Don't need me to go through them. What it's more like, okay, we understand fluency, but now how do we foster this in our classrooms? And I think, Howie, that you covered pretty much all the examples that of kinds of tasks that we can have in a classroom to practice and then foster this fluency. And I love to pose this as a solar system, right? And at the center of this solar system, and I promise we will go to an activity in the next slide, but hold with me for a second. At the center of this solar system, to develop fluency, what shines light is not practice, as I used to think. It is not practice. What shines light to all these planets is conversation. At the very center of developing fluency, the key is conversation, because it's very unlikely conversation, and of course today in a virtual setting conversation is harder, or it needs to go through the chat, but conversation in the sense that, and I might not, for instance, I love what you said, Howie, with your example of the butterfly, right? The butterfly with the dots on the ground. And I thought, the moment Howie said, oh, and some kids say this is a butterfly with the body and the wings, I cannot unsee it. But I could have been staring at that image for 10 hours on my own and never see a butterfly unless we talk about it, unless somebody next to me, if ideally a peer or the teacher, says, hey, I see it this way, or I see it this other way, unless that happens, it's very, very unlikely that these kinds of strategies arrive to every kid, right? So to me, at the center of fluency, there needs to be conversation, number talks, conversations, and of course through manipulatives and this communication part, right? But it's true that conversation alone, or conversation about what, right, doesn't travel far. So we have to shine this sun at the center of this solar system shines some planets. And forgive that some of these planets, or all of these planets, are quadrilaterals, very very weird planets. But it's to make the metaphor clearer, right? So what planets do we have? And for sure we can have other planets, but the ones that we consider central at Innovamat are the different strategies that Howie was sharing, right? We need to talk about the different strategies and build like comprehensive structures in our classrooms so that kids are exposed to these different strategies, and they not only rely on cross multiplication or whatever the trick is that day. And then there is others, right? The games. I'm sure you know many games that help develop fluency, routines. And let me arrive to practice, right? We have productive practice and, don't laugh, reproductive practice, right? Depending on the age where you explain about reproductive practice, depending on the audience, you have to be careful. But hold with me, this is not my term. It's a research term, and it has been there for ages. Productive practice as opposed to reproductive practice. Reproductive practice is what we're used to in traditional math instruction. The kill and drill, the worksheet with A, B, C, D, Z, right? That's reproductive practice, repeating a procedure, which we're not per se against, but it's most of the times boring, right? If you know the procedure, after a few repetitions, you're like, okay, why do I have to stay here if I already know this? And if you don't know, it's very unlikely that you magically develop the skill after 5 repetitions, right? So reproductive practice, this repetition of the same thing over and over, might be useful in very specific settings, but in general, you have better things to do with your kids. And we have better opportunities to be with them and practice and develop this fluency. And a big body of activities that we love at Innovamat are what we call, or what is called, productive practice. And instead of explaining you what is productive practice, let's do an activity and see it, okay? So here's the thing. We're gonna do a conversation around dice, right? If you are home and you have, or in your classroom and you have dice close, go get them as I introduce the activity. If you don't worry. You can just type on Google, roll dice, and they will appear in front of you, and you can work with that and just trust that the virtual dice work as well as the physical ones, or at least are not loaded. So here you go. We have two dice, and I don't need you to type in the chat because we're going to go for breakout rooms in a second. We have two dice, we roll them, and we try to find the difference between them, right? So the first question that I would love for you to start thinking is, okay, what results are possible and what results are impossible? We would start the activity like this with the kids, right? What results are possible and what results are impossible? And the kids can start saying, oh, zero is zero possible, is one possible? Can we have negative results? Well, if we're considering the difference, yes, no, all those questions appear at the beginning, right? And I love that, Howie, you were talking about subtraction as a distance today on the number line, and here is a good example. This is subtraction as a distance. We're not saying no, the first dice is the bigger number, the second. No, it's just the distance between the two dice. That's the result. Okay, so what results are possible and impossible? And then who will win the race? And we're like, what race? What are you talking about? Well, I didn't tell you, but there is a race. And we have some athletes that are going to run this race. And our job before seeing who wins is to guess, or in better mathematical terms, to make a conjecture on who is going to win, right? The only rule you have to remember is that we're finding the difference between the dice, and that result is the number of the athlete that will move one position forward. So imagine that we roll and we get a 4 and a 1, like in this example here. If we get a 4 and a 1, it's athlete number 3, that's the distance, who is going to move one position forward. So it will be three moving one forward. And now the question is, who do you think will win the race? Make a conjecture. We're going to go and break out rooms. And after the 4 or 5 people in the room make the conjecture and talk about the conjecture without spoiling why you think that conjecture is true, you then go place your bets, virtual bets, and we go for the experimentation. So take the dice, if they are real or virtual, it doesn't matter. Play some rounds and see with your group what athlete wins and if that matches your conjecture. Yes, we will be a few minutes in the central room just in case somebody is having some concerns or some questions, and then we will go back to the rooms, and we will visit you. Howie, Bernat, and myself will visit you in the rooms. So now let me try to do the breakout rooms real quick. Okay. Let's see. Opening.
We should just make sure that everyone is assigned to a room, as I
Yes.
heard that we left 2 people out the last time.
I don't seem to be able to assign people. Can you do it, Bernard? Why I cannot do it? We tried just before. Technology is how it works, but
It should be.
oh, let me. I see that the create again. Yes.
You should put
So
random.
yeah,
There you go. The rooms are created. All right.
and we're gonna move people.
Let's see. All right. So is that working?
It is working, but slower than expected.
Can just take 1 minute. That's okay. Should I join one of the rooms?
Yeah, please go
What?
ahead. I'm gonna stay for a couple minutes and then
She's oh.
All right, we're back. Is everyone back?
Yes, some people was saying that they were not added to any room. I don't know what happened. I saw some people maybe you gotta pop out and not accepted on time. I don't know. I'm sorry. We should learn better to do these breakout rooms.
Yeah, apologies for this.
Yeah, I hope either way that you were thinking on the task. I know thinking alone is sad sometimes, and it's precisely against what we were saying about conversation. Yeah, I was monitoring. I could not visit any room. I was monitoring that everyone was in a room, and I saw some of you that were not moving. I assume it's because of one of the options, and yeah. Anyway, so Bernard, Howie, do you want to share? Since you were in some rooms, what you saw, what happened, what interesting reflections, conversations that you had for like 2 minutes.
Howie, please go ahead. I'd love to hear yours.
Oh yeah, so Andrew and I were in a room together and we were talking about um we were thinking that one was the most prevalent because there's like 6 5, 5 4, 4 3, 3 2, 2 1. Definitely can't be 5 because you need a 6 and a 1. So we were debating on whether it's 0 or 1. We were just too lazy to make a grid. Like we knew we could totally get the answer if we just make a grid, but we were just trying to visualize it, whether it's between 0 or 1. So
It's funny that you say that we were too lazy for that, and it completely goes to the bullseye of problem solving. The moment you know the steps, I mean, it stops being a problem and it stops being that interesting. Sometimes there has value in the classroom to do exercises instead of problems. So things for which we have a procedure to go. And I'm glad you said no. I'm not doing that table. If I needed to, I could, but you had the intuition that that could help you find the answer. Um, Joseph shares a fraction, and we could ask, oh, but okay, 1 out of 10 times, so fractions relate, or 10 times out of 36, so fractions we open the door to fractions here. Bernard, do you want to share what happened in your room or any conversation, any insight?
I actually would love to open this up to anyone that wants to share. We can unmute, one person at a time, which is not ideal, but would anyone be open to sharing? I would love that. And I
Yeah, we
will.
have 10 minutes, so plenty of time.
And
Well,
I see people writing like some interesting questions that came up that definitely happened in our group that when we saw the answers, we're like, hey, like let's now come up with questions that we'd like, to explore further.
and we will go there in a second, but maybe we
Brittany,
can
do,
we
do
can
you
read
mind?
some of them.
Brittany, do you mind if I open your mic? I'll go ahead. And if you're open to talking, that would be lovely.
Uh,
It'll-
sure. Yeah.
Thank you.
I mean, we didn't honestly do anything very special. I was in a room with two other people. We did make a dice chart and we did do the subtraction and we got kind of zeros from the top left down to the bottom right. And then it just sort of is symmetrical from there with like ones and twos and threes. And we found a lot of the differences. So we said that if we were going to do like theoretical probability, that would be something like we would bet on number one because that shows up the most. And so we would assume that one would reach the finish line first.
Mhm.
We did talk about what would happen, like, if we got a four and a one, we were like, do we do one minus four or four minus one? So, like, is it negative or is it positive? But I was thinking, well, if we're at the starting line, we wouldn't really go behind the starting line. So we just said, let's stick with positives. But, like, what kind of options that would open up, and it would make the probabilities like a lot more vast, I think. But
And if you're working on integers, why not to open that door, right? It depends on the grade.
yeah, that was pretty much it. Thank you.
Thanks for sharing. No, and I love the distinction between theoretical and experimental probability, and that's an intuition that kids have very, very early. This is more about subtraction and about fractions and about having an excuse. I promise you to talk about productive practice, and I don't want to finish the session without this, but um, Imagine a worksheet, reproductive practice of subtractions between 6 and 0, right? Or 6 and 1 on the die. So imagine a worksheet with all these subtractions, one after the other one, right? And compare that to what we just did and all the mental math, or depending on the age you do this activity, even written math, written calculations if they need to, drawing the number line or using any of the strategies that you have been working on. This is productive practice, is giving the kids an excuse, something to work on, a problem, a situation, something to think about that will require, and this is the key, that will require a lot of practice of the same. And if you are a kid that already knows, like all of us already knows subtraction pretty well, we still can have fun in the mathematical sense of diving into the math practices and problem solving and finding a representation that helps us understand what is happening and experimenting. And all that is also valuable while we give time to those kids that might need a little more exposure and practice to get there and practice more about, in this case, subtraction, right? This is what in the literature is called productive practice, because we are practicing in order to produce an answer to an open question. In this case, it was, who do you think that will win, right? The race. And then, of course, if we roll only once, I always, every time I do probability, I have a weakness for probability. It's my weak spot. I love probability activities. So every time I would do an activity like this with the kids, I would go for only one roll. Imagine I roll the two die and I get 4 and 1. And then I go, okay, the difference is three. Three, I'm sure the athlete number 3 is gonna win. We saw that in one roll. Let's move on to another activity. And then what do the kids do, right? They panic. They are like, no, no, but no, we have to do more. I'm like, well, okay, let's roll again. I roll again. Oh, okay, I got now I got a 1. Okay, so it's 50-50. Sometimes one will win, sometimes 3 will win. Let's move on to another activity. No, no, no. Okay, let's do it again. And then at some point, I'm like, are you gonna like stop me every time? Or do we have a number of roles from which we feel comfortable? And in that silly playing dumb conversation, there's a powerful central idea of probability, which is the law of large numbers, right? The more you repeat an experiment, the more, statistically speaking, and with a bigger picture, the more you approach the theoretical expected probability, right? And that's the law of large numbers. When you do a lot of repetitions, and actually, just let me show you real quick a GeoGebra that we programmed time ago. This is rather old. Can you see my screen still? No?
We cannot
Okay,
see your screen now.
let me do it. Let me share this. Okay, can you now? This is a GeoGebra. I'm sorry it's not in English, but here we can see like rolls. So every time I roll, this is a 6 and a 1, so it was number 5 who moved. Another roll, that's 2 and 1, so it's number 1 who moved. You know how this works, right? And I can get rolling, 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 trust that this is a true random dice, and see who wins, right?
Voila.
Oof, 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 oof.
It's very tight.
And when you do that, after, of course, after experience, I wouldn't start like this with the kids, but after some moments, playing with a virtual simulator might be easier to talk with the classroom, right? So at some point, like, oh, okay, you want to change your bet, you want to change your conjecture. What made you change? And all this change in the conjecture is also important, because that is also the intuition that the kids have might keep changing, right? Why is 0 never going onwards, etc., etc. Also, of course, you can go 10 by 10. Oh, here number 2 is about to win. And what happens when you do only one race? Can you jump into conclusions with only one race? And all those questions are of course, worth exploring. Okay, and we're back to the presentation. Yes, and we have to finish in 2 minutes. So let's. Can you see the slides? Howie, is this what you were too mathematically lazy in a good way to do?
Yes, yes, absolutely.
Absolutely. All right. So, and I also colored them so you could see which one is more frequent, right? Which one has more odds to appear. Here you can have the difference between A and B, or in other words, more high school words, the absolute value of the difference between A and B, or the subtraction I minus B. And then you can see all the pairs of dice. And as you can see the distribution, right? Number 5 only appears when you roll a 6 and a 1 or a 1 and a 6. So out of 36 different options, 6 times 6 dice, or faces of the dice, There's only two of them. As you can see here, the probability of getting a 5, it's only 2 of 36, right? We could rewrite this as fractions or as ratios and talk about it and talk about
Albert,
what fractions mean in a probability context.
Stephanie is asking what grade level you'd say this is good for.
Ooh, I think that's a very good question for which I don't have an answer. Of course, I have my experience and I've done this in different grades, and I have some grades in which the conversations you can have can go beyond the simply subtraction. But what do you need to do this activity, right? To explore the fractions in this way, you probably need end of third, beginning of fourth grade, right? But if you are only talking about the subtraction and exploring and playing a little bit, you can do this activity in first grade. Why not?
And
Probably
Stephanie
the
in fifth, so I mean, definitely for fifth, I think that
fifth
would
is perfect. That's where we have it in the program. Fifth grade is perfect because then the conversation can be truly about the patterns, the conjecture, etc. So instead of killing that activity earlier, we do it in fifth grade. But you could potentially open it to much earlier. Why not? Or much later. Didn't you have fun doing your conjectures? And then just to finish, some variations as we were exploring, right? Adding the two dice instead of subtracting. That's the classical one, right? And how that changes the probability, the distribution. Now that you have seen the double entry table, you have more tools. So that's probably where you would start analyzing the problem is if I asked you, right? And it's a very well-known activity. That's the traditional one, the addition of two dice instead of the subtraction. Another variation, multiplying. How
Mhm.
did that change? What athletes do have to join the race, right? If we have multiplication. Oh, I don't want those many athletes. Okay, so multiply them and consider only the last digit. Is every athlete between 1 and 36 running? No. Which athletes are not running? What's the relationship with those athletes and prime numbers and all the questions that you could open from multiplying or rolling more than two die. You make the variations, right? You can think of any variation that comes to your mind. Actually, my favorite one is put kids in groups of 4, and with that I will finish, and ask each of the team members to take care of one operation. So imagine we're the 4 of us. I'll take care of checking the addition. You take care of checking the subtraction. Another one or the difference. Another one takes care of multiplication, and another one takes care of the maximum of the two dice, or the minimum of the two dice, or the division and taking the remainder, whatever you can imagine. And then we explore that from 4 perspective, and then I can go with my teammates to discuss what happened in my experimentation, right? All the variations, all the doors that can be open, and in the end with the same goal, which is give kids opportunities to practice with purpose, right? Not just because.
I love productive practice. Beautiful. Thank you so much, Albert. Maybe let's close how you put this slide, which we discussed and that I love as well. So if you want to say a word.
Oh yeah, thanks for being here. I'm very big on texting yourself one thing you take from PD sessions, just because if you don't remember it now, you're not going to remember it tomorrow. So I like to text myself maybe like 3 or 4 times a day, or else I'll forget things. So just text yourself one thing you'll take from this session. I really like the subtraction activity that you showed, Albert. So I'll be taking that.
And if you try it, of course, we will be happy to hear how it went. We're always open to feedback, so thanks.
Absolutely. Before we close, if you allow me for just 1 minute, I will share my screen. Maybe Howie, you can, or Albert, sorry, you can stop presenting. Um, I'll share my screen. Bam, bam, bam. You tell me if you can see it. Can you see it? Beautiful. All right. So just letting you know, two things, very brief. First, in 2 weeks from now, on December 4th, we're going to be running another webinar. This one always focus on both seeing the lens of the framework, and in this case, connected to the learning foundations in early childhood. It's a topic that matters a lot to us at Inomat, as we've been doing a lot of work on this specific front for the last 5 years, and also it's a part of the framework that's usually like less spoken about because it's part of the framework, but not of the adoption of curriculum materials. So, we would love for you to join. It's different topic from today, but connected nonetheless. I mean, how we begin to build number sense in those early ages is indeed a very important question, and it's one that we'll tackle. And last but not least, we would love to hear your feedback. We've been running these sessions. I mean, I'd love to know, what stuck with you. Also, I thought about timings, like 5 p.m. Is that a good time? Maybe slightly earlier or later. 1 hour 15, maybe it's slightly longer or sweet spot. I mean, any thoughts of things that you took away from today, things that stuck with you, that thing that you texted yourself? I mean, anything you can share, it's really helpful to us. We continue to, collaborate with these amazing minds, such as Howie, and that we continue, to drive the conversation in math education, as I believe is one of the things that ties us all together. So anyway, thank you all so much. Wishing everyone an amazing evening, and big hug to everyone. Thank you, Howie. Thank you, Albert.
Thank you so much.
Ciao, 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 ciao.